Qualitative inheritance versus quantitative inheritance is probably something you've never heard anything about. But what these two terms are talking about is whether the trait that we are looking at is one gene, is coded for by one gene only, or if the trait is created by the interactions of more than one gene. So, examples. When we're talking about pea plants, purple flower versus white flower is a one gene trait, and that one gene is simply dominant. So you either get purple or white, nothing else. And so if you look at the slide, it says qualitative traits are simple Mendelian and monogene. So simple Mendelian means like dominant and recessive, simple dominance. Monogene, mono means one, so it's one gene. And then you see where it says environmental effects little. So the environment has very little to do with whether the flower turns out purple or white. Quantitative, many gene traits, right? So you can see stature, height, intelligence, milk yield in cows. Those are complex traits. They're coded for by the interaction of many genes with each other. And so environmental effects can be greater, right? So moderate to great. So an example that should be helpful is height in humans. There aren't just We're not just either tall or short like some plants. Height in humans goes from very, very few people who are under 3 feet tall to very, very few people who are over 7 feet. Most people are somewhere between 5 and 6 feet something. And so if you look at this graph, you see that sort of bell curve. There are very, very few in the short end. There are very, very few in the longest end. Most people are somewhere in the middle. And when we see a graph like that, it tells us that it's a many gene trait.